Hi everyone, so in this video we are going to talk about solving an application problem with Simplex. So we've already learned both pieces we need from this because we've already seen maximization applications. We just solved them with graphing before. This one, the only difference is we're going to solve it with Simplex. So we already know how to set these up from whenever we did it with graphing. And we know how to solve stuff with Simplex now, so there isn't really anything new in this video. It's just going to be putting together two pieces that we've already done. Okay, so Peter Parker needs more money since he recently spent it all. He's going to sell some photos to the Daily Bugle. He has two options. He can take some pictures of nice scenery, or he can take pictures of Spider-Man. He only has enough space on his camera for 20 photos total. Each scenery picture would take him 10 minutes and earn him $50. Each picture of Spider-Man would take him 60 minutes and earn him $100. He has 5 hours to take the photos and get them all to the Daily Bugle before it closes. How many of each type of photo should he take to earn the most money? Okay, so first off, let's go ahead and start with the profit equation. Actually, before that, just to make things extra clear, let's go ahead and say what our variables are. So what we're actually trying to figure out is how many of each type of photo. So let's let x1 equal pictures of scenery, and x2 can be pictures of Spider-Man. Alright, so if we want to think about our profit equation, we want the most money. So we're going to look through and we're going to find the money for everything. So each scenery picture would earn him $50. Each Spider-Man picture would earn him $100. So that is going to be 50 x1 plus 100 x2. Next up, we need our constraints. So what is it subject to? Well, the couple things that we can't go past, first off, I see that he only has enough space on his camera for 20 photos total. So for that one, the total photos, which would mean x1 plus x2, both of those pictures put together, has to be less than or equal to 20. That's the first one. The other thing that we can't go past is he has 5 hours before he has to get them to the Daily Bugle. If he only has 5 hours, then we have to make sure we get it before then. So if the scenery pictures take 10 minutes and Spider-Man pictures take him 60 minutes, then to put that in an inequality, we have 10 minutes for every scenery picture, so that's 10x1, plus 60 minutes for every Spider-Man picture, so that's x2, is less than or equal to, and we have 5 hours, but we can't put 5 here because 10 minutes and 60 minutes is less than 5. Well, that wouldn't make sense. Since the 10 and 60 were in minutes, we need to put the 5 hours in minutes as well. So just multiply it by 60 and we get 300 minutes. Alright, with that out of the way, we are now ready to go ahead and start solving this. And by the way, Obviously, we can't have a negative number of either photo, so make sure you put that one. So if we're going to go ahead and start solving this with Simplex, first thing we need to do is we need to change the profit equation, and we need to change all the constraints to add slack variables to them. So our new profit equation is going to be negative 50x1 minus 100x2 plus p equals 0. Our constraints will be x1 plus x2 plus s1 equals 20, 10x1 plus 60x2 plus s2 equals 300, and x1, x2, s1, s2 are all greater than or equal to 0. And then we can go ahead and set up our Simplex tableau. So x1, x2, s1, s2, p, and then the number. On the left side, we start with our slack variables, and p. And then let's go ahead and start putting in everything into it. So our first constraint would be 1, 1, 1, 0, 0, 20. Second constraint is 10, 60, 0, 1, 0, 300. And then lastly, our profit equation is negative 50, negative 100, 0, 0, 1, 0. Okay, so first things first, we have to find our pivot. So negative 100 is the column with the biggest negative on the bottom. To find the row, we divide 20 by 1, get 20. 300 divided by 60 is 5. So that means row 2 is going to be our pivot row, which means that 60 is our pivot. So to start, we need to get that to 1. So we're going to take row 2 and divide it by 60. That will give us our new row 2. Alright, so let's go ahead and remake this. x1, x2, s1, s2, p, and the number. s1, x2, because x2 entered and s2 exited, and p. So row 1 stays the same, no change there. Row 2 though, if we divide everything by 60, we get 1/6, 1, 0, 1 over 60, 0, 5. Then our last row also stays the same for now. All right, we have our 1. So now we need to get everything above and below it to 0. We're going to need 2 row operations for that. We're going to do negative 1 times row 2 plus row 1 replaces row 1, and positive 100 times row 2 plus row 3 replaces row 3. All right, I'm going to go ahead and do these off to the side. I will go ahead and show you all of the work for it so that you can still check why you may have got one of these a little bit off if one of your numbers doesn't match mine. But here are those 2 done. So up on the right, you can see the row operations that I did. And then on the bottom left, we can see our new tableau. So pause it if you need that scratch work. But we are going to go ahead and focus on this tableau now. So unfortunately, we do have a negative on the bottom, which means we do need to go ahead and do this one more time. Okay, so it's going to be our column with our negative since there's only one. Then we're going to do 15 divided by 5/6 and 5 divided by 1/6, which are going to be 18 and 30. $18 smaller, so row 1 is our pivot row, and the 5/6 is what we are going to be using as our pivot. So to change 5/6 into a 1, we can either take row 1 and divide it by 5/6, or that's the same thing as saying 6/5 times row 1. Whichever way you want to do it is perfectly fine. They will get to the same result. So if we go ahead and do that, here is our next tableau. So this is just taking row 1 and multiplying it by 6/5. Rows 2 and 3 did not change at all. All right, next up, we need to go ahead and do our row operations again. So we have the 1. We need to change both of these into zeros. All right, so the row operations for those would be negative 1/6 times row 1 plus row 2, places row 2, and then positive 100 over 3 times row 1 plus row 3 replaces row 3. So again, I'm going to go ahead and do these off to the side. I'll show you all of the work, and we will get to our last tableau. So it should pop up right about now. And here is our final tableau. Again, go ahead and pause the video if you need to take a look at the row operations and the work behind them. But let's take a look at this final tableau now. So luckily, if we look at our bottom row, they're all positive. So that means we are done. We just need to say our answer now. So we're looking for 3 things: x1, x2, and p. x1 is 18. x2 is 2. And p is 1100. So we have a max of 1100 at 18.2, but remember, this one's a word problem. So that's not going to be our final answer, because if we were given the problem in words, we want to say it back in words. We want to say what these numbers mean. So we have a max of $1,100 made if Peter takes 18 scenery pictures and 2 pictures of Spider-Man. And that is our final answer. So again, this is just 2 things that you've already done being put together. So that is it for all of these Simplex videos. So let me know if you have any questions. Otherwise, I will see you in the next unit. Thank you.